Robin Hood Radio presents Your Health with osteopathic physician Dr. Kim Tripp, a show presented monthly on Robin Hood Radio, discussing the challenges faced and the solutions that are available for keeping vital health and well-being throughout our lives. And now, here's Dr. Tripp.
Hello, everyone. Welcome to Your Health with Dr. Kim Tripp, osteopathic physician. This is the health show created to bring you vital information and discussion of all sorts of health issues on your mind and in your life from the unique perspective of traditional osteopathic medicine. So first, as we always do, let's clarify what osteopathic medicine means. Osteopathic medicine is practiced by fully licensed physicians in the United States with a DO degree, a Doctor of Osteopathic Medicine degree. Our practice is based on the essential relationship in all living things between structure and function. In other words, the natural interdependence between anatomy and physiology, or that between the physics of the body and its chemistry. As osteopathic physicians, we use our comprehensive and precisely detailed knowledge of anatomy and physiology to promote health and healing in our patients. We work gently with our hands to help your body restore optimal function based on optimal structure. Our medical specialty is therefore called osteopathic manual medicine. We receive uniquely in-depth training in anatomy and physiology and their relationship within your body in the context of a full physician's medical training. Only U.S.-trained osteopaths are fully licensed physicians and have all of the current medical pharmacopoeia, nutritional science, and full medical training at our disposal. This means that your individual treatment may include a wide range of approaches, but will always be founded on our gentle hands-on work. We practice from the unique perspective of first looking for the health in our patients rather than merely finding illness and disease. Our practice has been especially effective for, but is not limited to, musculoskeletal and other structural issues, as well as problems like chronic headache, gastrointestinal problems, post-concussive syndrome, sleep disturbance, allergies, and many, many other problems. We work together with you, the patient, to help you build health and vitality in your body, mind, and spirit as the solution for your health problems, rather than only treating the disease symptoms. So in the radio show, we tackle health issues from this point of view. What can we do to help you build your health and vitality in order to prevent and heal injuries and disease? And we do that by giving you some basic information about the problem to help you understand what's happening, as well as offer solutions and guidance for helping yourself to heal and stay healthy based on our clinical experience with patients in our practice. Before we get started on today's topic, let me just remind you that you can listen to all of the prior Your Health shows online at your convenience, such as those on back pain, nutrition, carpal tunnel, etc., by going to the Goldman Tripp website, www.goldmantripp.net. Click on the radio show icon, then scroll down and click on the individual show by topic. There are now nearly 50 shows available. You can also get the most recent show podcast right on the Robin Hood Radio website itself in the on-demand section. It's amazing. What we're going to tackle in our most recent and upcoming series of shows is the extraordinary human immune system. This system is clearly on everyone's mind right now in the context of the current pandemic. The human immune system is a highly complex system of interactive organs, tissues, and specialized cells that serve to protect the entire body from foreign substances and toxins, from invading microbes like bacteria, fungi, and viruses, and from our own cells gone awry by producing the immune response. The immune response is a multi-layered biology that ultimately uses many different normal cells, tissues, organs, and physiological strategies within our own body to clear these problematic substances, invaders, or abnormal cells from the body. Normal immune system development and function relies on one basic biological principle. That is, the ability of that immune system to recognize substances, organisms, and cells that are in or on the body as being either, quote, self or other, and then to respond with the appropriate physiological interaction with that substance, organism, or cell. It sounds simple, but in order to function successfully, that simple biological principle must be manifested as a nearly infinite array of sensing and response mechanisms throughout our entire life, starting in utero and adapting and evolving through birth, infancy, childhood, adulthood, and old age. So today we're going to continue with our exploration of that miraculous system, and we'll delve into details much more deeply as we work through the series. Remember, as we dive into this discussion, that the immune system has the complex task of recognizing what belongs to the self and what is other, and then deciding whether or not the so-called foreign material or microbe is harmful or beneficial. Not all microbes are harmful. We have an enormous microflora of thousands of kinds of diverse bacteria and yeasts that are meant to live in various parts of our body in appropriate relative proportion to each other. So not too much of this one, not too much of that one, but lots of this one, and keep within their appropriate location, colon versus eyelid, for example. And the immune system has to be able to recognize all of that and help keep it in balance. Remember that in prior shows, we considered the physical components of the immune system at the organ and tissue levels. To review briefly, there are several organs and tissues that play foundational roles, including skin, mucous membranes of the mouth, nose, airways, reproductive and urinary tracts, tonsils and adenoids, the whole gastrointestinal system, the liver, the thymus gland, the spleen, our bone marrow, and of course, lymph nodes, tissues, and lymph vessels. In the last show, we began exploring immune function at the level of the specialized cells involved with all of these organs and tissues, and at how these are functionally organized in the body in terms of an immune response. To review, there are two basic systems of immune defensive response: innate and adaptive. The innate system is a kind of rapid first responder with generalized responses to all intruders and abnormal cells. The adaptive system takes longer to respond, as it provides specific antibodies and defenses tailored to the specific intruder. The adaptive system is activated by the innate system. Both systems exist to defend us from potentially damaging organisms like bacteria, viruses, fungi, and worms, collectively called pathogens, referring to their capacity to generate pathology, i.e. disease, as well as harmful foreign materials and toxins. Both the innate and adaptive immune systems work together in an interdependent approach to dealing with pathogens. Pathogens directly activate innate immune responses against infection in all multicellular organisms. In vertebrates, though, pathogens and the innate immune responses they cause stimulate adaptive immune responses, which then help fight the infection with more specifically targeted defenses than the innate system can offer on its own. The innate system is therefore more generalized and faster to respond. The adaptive system generates specific responses to recognized entities and therefore is more targeted, but also therefore takes longer to mount a response. The innate system, once activated, catalyzes the activation of the adaptive system. Adaptive immune responses are slow to develop on first exposure to a new pathogen. It can take a week or so before the adaptive responses are effective. By contrast, pathogens can create problems much more rapidly than the adaptive immune response can get up and running. For example, certain types of bacteria can produce almost 20 million offspring in 1 hour from one single bacterium, creating a rampant infection in 1 day. Therefore, during those first crucial hours and days of exposure to a new pathogen, we rely fully on our innate immune system to defend us. The innate immune response is well named, as it refers to the set of immune responses you are able to use shortly after birth. Innate immune responses are not targeted to a particular pathogen in the way that the adaptive immune responses are. In the last show, we reviewed the specific types of innate immune physical barriers and cell types and how they work together. Recall that the innate leukocytes, in other words, white blood cells, include natural killer cells, mast cells, eosinophils, and basophils. And the innate phagocytic cells, those eating cells, including macrophages and neutrophils, and all function within the immune system by identifying and eliminating pathogens that might cause infection. In today's show, we will discuss the crucially integrated component of the innate immune response, that is, the inflammation response. The word inflammation is widely used and misused at times to describe all kinds of discomfort and pathologies. And to make matters more complex, there are numerous types and stages of inflammation. So let's first look at the actual basic definition and accurate descriptions of inflammation before putting this in the broader context of our innate immune response. Inflammation is the immune system's frontline response to harmful stimuli, such as pathogens, allergens, damaged cells, toxins, or irradiation. The inflammatory response cascade removes the sources of the harmful stimuli and initiates the healing process. Inflammation is therefore a crucial defense that is essential to health maintenance. Usually during acute, in other words, sudden or short-term inflammatory responses, the cellular and molecular processes minimize impending injury or infection and thereby allow for a return to normal and thereby resolution of the acute inflammation. However, if the inflammation does not resolve and remains active, uncontrolled acute inflammation may become chronic, in other words, long-term, contributing to a variety of chronic inflammatory diseases and health problems. At the tissue level, inflammation is characterized by redness, swelling, heat, pain, and loss of tissue function, which result from the local immune, vascular, and inflammatory cell responses to infection or injury. Important events that occur during the inflammatory process include vascular permeability changes, meaning the small blood vessels become leaky, white blood cell recruitment and accumulation, meaning defending white blood cells become activated and are drawn to and accumulate in the affected area, and inflammatory mediators are released, meaning specialized cells and compounds are released that help to stimulate and manage the inflammatory response. Various pathogens and injuries, such as infection, tissue injury, or cardiac infarction, can induce inflammation by causing tissue damage. The stimuli of the inflammation can be infectious or non-infectious. In response to tissue injury, the body initiates a chemical signaling cascade that stimulates responses aimed at healing affected tissues. These signals activate and stimulate white blood cell migration from the general circulation to the sites of damage. These activated white blood cells, among other things, produce inflammatory compounds called cytokines that stimulate inflammatory responses. Cytokines are important native compounds that modulate our immune response to infection or inflammation and regulate inflammation itself via a complex cascade of interactions. However, excessive inflammatory cytokine production can lead to tissue damage, vascular and circulatory changes, organ failure, and ultimately even death in a kind of out-of-control inflammation perpetuation loop, sometimes called a cytokine storm. But the inflammatory response involves not just cytokines, but relies on a highly coordinated population of many different cell types. Activated macrophages, monocytes, and other cells mediate local responses to tissue damage and infection. At sites of tissue injury, damaged cells release compounds that trigger the inflammatory cascade, which attract neutrophils and monocytes. The first cells attracted to a site of injury are neutrophils, followed by monocytes, lymphocytes, including the famous natural killer cells, T cells and B cells, and mast cells. Monocytes can differentiate then into macrophages and dendritic cells and are recruited to damaged tissues. Inflammation-caused immune cell alterations are associated with many diseases, including asthma, cancer, chronic inflammatory diseases such as inflammatory bowel disease, atherosclerosis, diabetes, and most autoimmune and degenerative diseases. That is the majority of non-infectious human disease. Neutrophils, those generalist security guards which target microorganisms in the body, can also damage host cells and tissues. Neutrophils are key mediators of the inflammatory response and are involved with activating the famous T cells, as well as with releasing factors that attract other specialized cells like monocytes, lymphocytes, and mast cells. Monocytes can differentiate again into macrophages and dendritic cells and are recruited into the damaged tissues. Mast cells are largely found in and around connective tissue, skin, mucous membranes, and other boundary tissues. They are effector cells that initiate inflammatory responses and help start the cascade. Activated mast cell release a variety of inflammatory compounds, including cytokines, chemokines, proteases, prostaglandins, leukotrienes, sirglycin, proteoglycans, and the infamous histamine. They are therefore big players in allergic responses as well. To prevent appropriate, helpful acute inflammation from turning into persistent, potentially harmful chronic inflammation, the inflammatory response must be suppressed once it is not needed to prevent additional tissue damage. Chronic inflammation occurs when acute inflammatory mechanisms fail to ameliorate tissue injury and therefore cannot be relieved. In addition to the autoimmune diseases mentioned earlier, chronic inflammation may lead to a host of other diseases, such as cardiovascular disease, atherosclerosis, type 2 diabetes, and cancers. Acute, short-term inflammation is essential to healing because it stimulates blood and lymphatic flow, inhibits microbe proliferation, recruits all the immune defenses and specialized immune cells to the site of the injury or infection, and stimulates the physiological rebuilding and repair cascades at the cellular and tissue levels. Chronic, long-term, persistent inflammation, on the other hand, has long been recognized as a major cause of disease. It is estimated that some 15% of human cancers are associated with chronic infection and inflammation. Chronic inflammation-mediated tissue injury is observed in many organ systems, including the heart, pancreas, liver, kidney, lung, brain, intestinal tract, and reproductive system. So how does the body know when to interrupt the inflammation cascade and return to the non-inflamed state at the appropriate time? And how does this regulation go awry, leading to harmful chronic inflammation? A complex interplay of factors released from the healing tissue inhibits ongoing inflammatory responses and allows for physiological resolution of the inflammation. If healing is delayed or prolonged, these inhibitory factors are in short supply, so the inflammation continues until the healing process supplies sufficient inhibitory factors to ramp down the inflammation. If this continues for too long, it becomes increasingly difficult for the healing itself to occur, and the inflammation then becomes chronic and even more difficult to ramp down, so it becomes self-fulfilling. What can we do to help prevent this problem in our own health? Make sure to take care of any infections or injuries to optimize appropriately rapid healing and recovery. Avoid inflammatory foods and beverages like sugar, starch, alcohol, and red meat. Get plenty of regular stretching and exercise. Get 7 to 8 hours of sleep a night and drink plenty of plain water. All of these habits help to minimize baseline inflammation in our physiology and are especially important when we are recovering from any injury, surgery, and/or infections. So this was a very brief overview today of the inflammation system as an aspect of our innate immune system. Remember, inflammation is an important first step in healing and preventing injury and disease. So the goal is not to suppress all inflammation. However, we do want to prevent chronic inflammation and therefore want to do everything we can to help our body's normal physiology keep inflammation in balance. It's important to remember that all of these immune responses are generated by organs and cells that are physical entities that can suffer from three-dimensional restrictions, contractions, twists, and contortions, such as limited diaphragm excursion, muscle spasms around the organs or lymph vessels, compression of soft tissues, or other issues that can impede blood and other fluid flow and/or lymphatic drainage. All so important for the management of inflammatory responses, thereby negatively impacting organ and immune function. So the physical health and well-being of these organs and tissues is equally as important as their biochemical health and well-being. Which brings me back to osteopathy and the close of today's show here with a reminder that an osteopathic physician who is a specialist in osteopathic manual medicine can be very helpful for immune issues of all kinds. Working gently with our hands, with the involved organs, nerves, vasculature, fascias, capsules, and associated tissues to release restrictions in the physical tissues of the immune organs, the diaphragm, the chest, and the involved blood and lymphatic flow, as well as to help balance the autonomic nervous system function based on anatomical detail, and to help with nutritional issues and support for whatever procedures or treatments you may be going through. Recall that all of the immune system is a complex physical entity with connections between all the parts that need to be open, flexible, and moving freely, with excellent neural conduction from the nerves, optimal arterial and venous blood flow, and lymphatic drainage to remain healthy, vital, and functioning normally. Well, I'm out of time again. Thank you so much for your attention to Your Health with Dr. Kim Tripp. Remember, you can email your comments and suggestions for topics to yourhealth@robinhoodradio.com. If you have a health issue yourself and would like to find out about how we might be able to help you in our practice of traditional osteopathy, we are at our offices in Sharon, Connecticut. Dr. Kim Tripp and Dr. Andrew Goldman, Goldman Tripp Osteopathic Healthcare, 860-364-5990, with evening hours on Wednesdays and Fridays, or on the web at www.goldmantripp.net. Well, I'll be looking forward to being with you next time. Till then, you take care of yourself, enjoy your health, and thank you for listening.